Welcome to Scanner School. This is session number 151 of the podcast. All the session notes can be found on our website at scannerschool.com/session 151. Before we start this week's podcast, I'd like to take a moment to thank our Patreon supporters. Patreon is a month-to-month sponsorship platform. We have 3 different support tiers, each with different benefits. But the most valuable tier is our $5 a month tier. This equates to sponsoring the podcast for about $1 per episode. Now, not only do our $5 Patreon supporters receive the podcast early, but they also receive a commercial-free version of the podcast delivered directly to their podcast player. Some may say that the included Squelchy sticker pack that is mailed to your home is the best benefit of the $5 level, but I think it's the community or the club that is growing at this level. You see, we meet once a month on Zoom and we have a roundtable discussion about scanning, ask questions, offer advice. Some of the members are answering other people's questions, and we just talk with our fellow Scanner School classmates. This is an exclusive group for our $5 Patreon members. Now, again, if all this wasn't enough at that level, you'll also receive discounts to upcoming Scanner School courses and offerings. Now, you can help support Scanner School by going to www.scannerschool.com/Patreon or www.scannerschool.com/support. Now, I'd like to thank all of our Patreon supporters at all levels, and they are Buzz Gold, Chris Paris, Craig Harper, Dan, Ed Walsh, Eddie K, Edward Dufour, Glenn Bryden, Guy Lee, Jackson Friedman, James Felling, James Peruta, Jeff Block, Jenny Taylor, Jim Heinrich, John Goldenberg, Ken Newberry, Kenneth Fowler, Kevin Zwicky, Lenny Bauer, Mark Thompson, Mark Beebe, Michael Kroger, Paul Teal, Raymond Hill, Richard Armstrong, Ronnie Bach, Sal Marandola, Signals Everywhere, Tim Mazza, Ten Glendy, and William Arcan. Now let's start the podcast.
Welcome to The Scanner School, a podcast dedicated to the scanner radio hobby. Class is about to begin. Here is your host, Phil Lichtenberger.
Welcome to Scanner School. My name is Phil Lichtenberger, and my amateur radio call sign is W2LIE. Today's podcast is sponsored by East Coast Pagers, your emergency alerting specialist. You can visit East Coast Pagers online at eastcoastpagers.com. And of course, by our Patreon supporters. If this is your first week joining us for class, or if you're a weekly listener, again, welcome to this week's podcast. Today, we are talking about combining antennas and the hardware required, and also why you would need to or like to combine antennas. And it all comes to dollars and cents here. We like to combine antennas if possible because coax isn't exactly cheap, right? Coax, especially LMR 400, which is what we recommend in the scanner radio hobby, is probably close to $1 a foot. So if you've got multiple different antennas, this can get very costly. Plus, if you've got multiple antennas, how do you bring them all into a single radio? For example, maybe you have a discone antenna for general coverage, but need a Yagi for, say, 800 megahertz because simulcast. What do we do here? Do we run 2 coax lines from the antennas into our homes and then run one Yagi to the one Yagi to one scanner and dedicate that one scanner to that one system and then everything else to the other scanner? Well, what we can do is we can combine both of those antennas together so that your scanner uses this discone basically for general receive purposes, except for 800, which means we'll be using the Yagi antenna strictly for 800 megahertz. This is one of those crazy advanced things that we can get into when we go down the rabbit hole of scanner radio listening. So let's look at one of the radios I have on my shelf. We're going to flip this around a little bit, and then we're going to start really explaining things for you. I have an ICOM ICR100 receiver. It's a general receiver. It has 3 inputs in the back of that radio. The radio itself covers from 0.1 megahertz up to 1.8 gig. So there's 3 inputs in the back of this radio. The first input receives or is for 0.1 to 50 megahertz. The second port is from 50 to 800 megahertz. And the third and final port goes from 905 to 1856. Now, if you're thinking of following home, you realize there's a gap in the cellular band from 800 to 905. But we'll look past that for now. So again, how do we run 3 antennas to this one receiver? Or how do we split one antenna into the 3 lines that come into the receiver? Right? This is part of what we're looking at here. Just examples of what we're looking at. So again, welcome to the world of RF combiners and splitters. So today we're focusing basically on duplexers, diplexers, triplexers, and the other forms of these plexers that are out there. So first and foremost, what is a diplexer? And to clarify, a diplexer is not the same as a duplexer. And we're going to talk about the differences at the very end of this podcast. And let me tell you, coming from the amateur radio world into the commercial world, where in amateur radio we use the term duplexer, and in the commercial world we use the word diplexer, they're completely different things. And it took a while for me to kind of understand the differences here, because they're the same but different, or they're different but the same. So we will see what that all means at the end of the podcast. But a diplexer simply is a 3-port device. And you can use diplexers to combine or split signals depending on which way you spin that diplexer. Basically, you have a low port, you have a high port, and you have a common port. So diplexers are basically built around the fact of an LC circuit, which basically means you have a low-pass filter on one of the ports, a high-pass filter on another port, and they basically mean that they reject or they filter out anything beyond a certain set frequency. So anything lower than X or anything higher than X. And you have to read the label on all of these pieces of hardware to make sure they're going to work for your specific needs, okay? So again, we could take this diplexer and bring in a low antenna, a high antenna, and send it out to our scanner radio. But why do we want to use a piece of hardware like a diplexer instead of just using a T connector or some other generic combiner or splitter that's out there? So let's look at physics really fast. We're not going to make this painful, but you have to understand why diplexers are important, triplexers, whatever else we're going to be using here, and not just plugging in 2 antennas into a single line of coax using a T connector. Radio waves basically are sine waves. So let's think of them as waves in a body of water, right? This is something that we can visualize here. And we all know that even on a calm day, water rises and falls over a set period or a frequency, right? So let's look at this a different way. We have a pylon that's in the water, right? That pylon is pounded into the bed of the lake bed, the ocean, whatever it is. I don't know, the ocean might be too big, but you know what I'm saying, right? In this body of water, we have a post that is drilled in, and it doesn't float. It's stationary. And we can watch the water as the water rises and falls with the wake or the waves, moves up and down on this vertical post that's in the water, right? Over a set of time, that is our frequency, like we just said before. So now we've got our mental picture. Post in the water, up and down, up and down, up and down. Well, what happens if we create another wave in this same body of water on the same frequency? Let's not combine different things here. We're going to just talk all the same, right? So what happens here? Well, if the 2 waves that we're generating are in sync, then the highs will be higher and the lows will be lower. Everything else will be in sync. What happens when it happens? That means that the amplification happens, right? We've amplified this signal. We've amplified the peak and valley or the peak and trough of this sine wave. But what happens though if we're slightly out of phase now? Well, we have the potential now to attenuate our signal. Because if we're 180 out of phase, what happens now? We have a complete negation. So the high is the peak of the wave matches the trough of the second wave. So now instead of being as high as it should be, it's a lot less than that. If it's slightly out of phase, you could get all funny things happening here. So this is why it's very important to isolate our antennas. We want to make sure that we have one antenna through a set frequency range. We don't want to have multiple antennas doing the exact same frequency range unless we have a very specific need for it, such as a Yagi antenna array, radar array, or something like that that's set for a fixed frequency that is also a tuned match antenna system pointed at the same direction which means we are using the antennas to get gain off of things. We're not talking about that on the roofs of our houses on omnidirectional antennas. Okay, there's a big difference here. And again, radar dishes, EME, Earth, Moon, Earth, those kinds of deals, there's a whole other ball games that we're talking about here. Right? We're just talking about general scanning, receiving here. All right, we can go off on a whole nother tangent here, and that is not what we're getting ourselves involved with today. Believe me, I'll put you guys all to sleep. You'll crash into trees. Trust me. So, what happens though if we have our antennas now? Right, we've got this established. Okay, I've sold you. Right, you're going to bring one antenna in on one port, one antenna on another port. But what happens though if we need more ports? Well, we could always stack diplexers. You can get a diplexer that has, say, 0 to 50 and 50 to, a gig. And then you have another diplexer that does 400 and lower and 400 and higher. And you could stack them in together and basically build yourself a triplexer. But why would we want to build a triplexer if we can just go out and buy a triplexer? And we also don't like to stack equipment like this because you have what's called insertion loss, which basically means you're going to take a small dB hit because you're introducing something into your receive path. Now, is this going to be something you're going to notice on your scanner? Probably not if your signal is strong enough. But if you're getting in just barely legible reception on a channel or something like that, yes, that could basically eliminate that frequency from being received. That can happen. So again, we want to limit the number of combiners or splitters that we're adding into our network. So basically a triplexer allows you to bring in 3 different antennas or split one antenna 3 different ways. Triplexer, just like a diplexer, has a low pass and a high pass, but also they've got a band pass in the middle, if I'm not mistaken. So again, let's talk about real life examples here. Again, we talked about my ICOM ICR100, which has 3 antenna ports. Again, as a refresher, 0.1 meg to 50, 50 to 800, and then 926 to 1.8 gig. So if we run a single disc cone antenna on one coax line down into my Radio Shack, I can then plug a triplexer into the radio's end of the coax and split the signal 3 different ways. And now I can get each part of that frequency into the correct port on my receiver. Well, let's spin it around and talk about how we would use this on a scanner radio, a typical scanner radio. Let's imagine we have to make antenna specifics on our, specific antennas per band because we really want to optimize thing here. So let's just say we have a disc cone antenna that we want to use from everything below 140 megahertz, okay? Because I have a great amateur radio VHF and UHF antenna that has gain on that part of the band, right? And we're interested right now, even though it's an amateur radio antenna, it'll work great on 150s and even in the 450s to 470s. And then basically, I'd like to have, so that's our 2 antennas right there, right? We got a disc cone for general receive below 140 megahertz. We have our amateur radio dual band antenna with gain, again, Omni. And then maybe we went out and we bought an Omni gain antenna with some gain on it. We have an omnidirectional antenna with gain on it for 700, 800 because we wanted some gain there. Now, again, side note, disc cone antennas don't have gain. That's why we have a special condition here where we have amateur radio equipment on VHF, UHF, and a commercially available antenna for 700, 800. So assuming now I can find a triplexer with the right filtering in it, I could, on my roof, run the disc cone antenna to the low band antenna, the low band port. I could run my VHF, UHF antenna to the mid band port, and I can run the 700, 800 antenna into my high band port. Then run the triplexer that's on my roof now, next to my antennas, into one coax cable and bring all 3 antennas down into my shack using one coax line. Now, with this method now, I have really improved my reception because I have antennas with gain on both VHF, UHF, and 700, 800. Now, I am sacrificing possibly reception in, say, the 300 range, the 200 range, so my mil aircom might be taking a hit here. But That's the trade-off that we're working on here, okay? In this example. Another example might be just, again, use a diplexer, like we said earlier, and have my disc cone be general coverage up to past the T-band, and then a 700, 800 antenna, right? It all depends on what it is, what your needs are. But these are all examples of how you may want to set up a radio to optimize your antennas. Now, if you want to go more than that, or maybe you can't find a triplex with the right filtering, a quadplexer, if you think a quad is 4 ports now, might have better filtering and have smaller gaps for what you need to have brought into your house and your antenna system. So again, there's hardware out there that lets you kind of connect different antennas and combine them into a single coax line. So now, on the other side of this break, we are going to talk about a little bit more. We're going to talk about some more high-end stuff, and we're also going to explain the differences between a diplexer and a duplexer. We'll be right back. Did you know there are ways to help support the Scanner School podcast that doesn't take any time or any extra money on your part? If you go to scannerschool.com/support, you will find we have several ways that you can continue to do your online shopping and help support us. We have links to Amazon. If you click on our link before you go to Amazon, anything you buy from there will help support Scanner School. Now, if you're in the market for a brand new scanner, an antenna, other accessories, we have links to Scanner Master, where you can not only purchase a scanner and accessories, but you can also get your radio programmed. And by clicking on our link before you buy, you are helping to support the podcast. Now, if you're in the market for software, we have links to Butel. And if you want something new to you, we also have links to eBay. Again, just go to scannerschool.com/support before you make your purchases, and you are helping to support Scanner School at no additional cost to you. This session of Scanner School is sponsored by East Coast Pagers. Now, East Coast Pagers is one of my online companies, and we are a Unication, Apollo, and Swiss phone dealers serving the North American market. Now, if you're looking for a personal use pager or one for your department, we can get you a quote at the very best prices. So why does a company like East Coast Pagers support Scanner School? I think that every scanner radio user should at least put one pager in their collection of radios. The reason why is very simple. It frees up your scanner to just do scanning, and then you have one radio that's dedicated to your local fire activity. Now, with a pager, you can have voice storage. You can do tone outs. You can keep it silent. You can go back the next day and listen to what you've missed overnight. It's more than you can do with an out-of-the-box scanner. And with today's pagers having multiple frequencies and even having multiple channels in a scan list, like the Unication G1 can do 8 channels in a scan list. It has 64 memory channels, and out of the box, it comes with 11 minutes of stored voice and a desktop charger. The G2s to G5s, they do P25 Phase 1 and Phase 2 in simulcast environments with stored voice, paging on conventional NP25. Oh, and they're upgradable too to DMR Type 1 and Type 2. They are more rugged than today's consumer-based scanners. And with a pager like a Swiss phone S-Quad, you won't even realize you're wearing one. It'll help keep you informed as to what's going on in your neighborhood. So again, eastcoastpagers.com or contact me directly, phil@eastcoastpagers.com. Do you have a new scanner? You're having problems understanding how it works? Maybe you're new to the entire Home Patrol database of programming and you can't figure out Sentinel. Did you get a new SDR and you're trying to figure out how to install it? Or you want to learn how to use Unitrunker, DSD Plus, maybe set up a PieAware, or even just make some changes and you don't understand how the system and the equipment works? The podcast might be great for you, but maybe you need a little bit more of one-on-one help with setting something up. I'm available to do just that with you with our private tutoring sessions. You can book me online by going to scannerschool.com/consulting for a 1-hour session. And it's great because we can actually share computer screens remotely, and I can guide you through step by step as if I was sitting right next to you. So again, book me for an hour at scannerschool.com/consulting for your scanner radio one-on-one tutoring session. National Communications Magazine is your personal library of scanner, CB, GMRS, FRS, MURS, and two-way radio articles written by the best minds in the business over the past 3 decades. Your NatCom personal online access account allows you to download the newest issues of America's Hobby Radio magazine, as well as back issues too. So visit natcommag.com to download your free sample issues and sign up today. That's natcommag.com for National Communications Magazine. Okay, so let's talk about some more advanced antenna combining. What happens if the antennas we have on top of the house we want to combine into a single coax line and you split them again at the bottom for certain radios on certain specific bands? Well, absolutely, you could do something like that. And again, let's talk about a real-life example for this. Let's just say at the bottom in our Radio Shack, we have a VHF Marine radio. We have a UHF commercial radio. And we maybe have a 800 megahertz radio or just a scanner we want to dedicate to 800 megahertz. Well, we want antennas that are specific for those bands as well. So we have a VHF Marine antenna on the roof. We have a decent UHF antenna with some gain. And we have a 700, 800 antenna, again, with gain on top of the house. So we got 3 antennas up there. And we have 3 radios at the bottom that we want to split those antennas back into. Well, what we can do is we can put a triplexer on the roof next to our antennas. And we can combine all 3 antennas into the triplexer, as we did on the example before we had our commercial break. Then at the bottom in our Radio Shack, we can then put another triplexer and break those signals back out again and send the VHF signal just to our VHF Marine radio, the UHF signals straight to our UHF commercial radio, and the 800 signals back over to our scanner or 800 megahertz radio. So this is a great way of combining and splitting signals through multiple antennas and sending them back out to multiple radios. Again, over one coax line, which remember is about $1 a foot. So this is a pretty cost-effective method of doing this. So now let's go to another more advanced thought here. What happens if we had to point a Yagi antenna to the east to pick up a 800 megahertz system, and we've got to point another one to the west to pick up another tower on a completely different 800 megahertz system? Then what happens? Well, you don't want to pick things up out of phase, so you can't combine the 2 antennas using the T. And you're also going to want to separate these antennas, right? You don't want them on the same height. You're going to want to put some separation in the height. And I don't have anything I can recommend to you right now, but there's definitely calculators online that can help you out there. So let's just say, for example, round number, we'll just say 3 feet. So you'll want maybe the antenna that's going to the west at one height, pointed to the west, and then your east antenna, it will be 3 feet below that antenna pointed in the opposite direction. Now, again, we do this because if you mounted the antennas at the same height, back to back, they will interact with each other, and they will change the pattern and also the frequencies that the antennas are used for. Now, how am I going to bring this into the house? This is the tough one. Well, there's a couple of different ways we can do it, and truthfully, you'd either set up a dedicated coax line for each antenna, either a dedicated home run into your shack, or you'd bring it in with a combiner on another antenna, but never together. That's the trick here. I wouldn't bring these 2 antennas in together. The only way I would ever do this, if you wanted to bring them in together, is one of 2 ways here. I would add a antenna switch. Well, okay, that's great. An antenna switch where? Well, you can always bring an antenna switch into the shack, AB switch, ABCD switch, whatever you want to call it, and you can pick your antenna based on your ABC switch or your AB switch or whatever you want to call it, right? But that's hard, right? That basically means that it's either this antenna or that antenna. Well, you could also have a tower-mounted or an outdoor-mounted remote antenna switch. And basically, you've got a console or a selector switch on your desk, and you plug each antenna on the mast or on your roof or on your tower into its own port. And each port then, is separated from the other port, but they share the same coax line. And then what you do is when you're in the shack, you say, I want to do antenna A, you press button A, and it makes the relay connections up at the mast, and you have antenna A receiving. Likewise, you want to do antenna B, click antenna B, then you receive off the other antenna. So again, this is a way to do it. But really, the only way to combine these two on the same line is to use a duplexer. Now, duplexers are big and they're bulky, and really, I don't recommend putting them outdoors. These are more in line with things that something you'd want to put outside. And a duplexer basically allows you to share a single antenna between a transmitter and receive. Typical when you have very, very, very small gaps between input and output. Like again, for the amateur radio world, right? You can be 0.6 megahertz off in frequency. use a duplexer, and you can share the same transmitter-receive line with separation between the transmitter and receive. So if you're going to use a duplexer, basically on this example of two Yagi antennas pointing east and west, you've got to remember too that you can never have overlapping frequencies. And you've got to tune the duplexer so that the highest on one isn't overlapping the lowest of the other. So it's a more difficult situation to be in. If you're going to go to the point of running separate antennas this way, I would just recommend dedicating one coax line, and bring them in separately to each antenna. Again, we've also got to worry about too, if we're going to separate antennas this way, not only the two of them talking together on the same coax line, but what happens when you've got propagation delay? Imagine you're picking up you got an antenna pointed to the east, and you're picking up an east tower, but that signal reflects off a water tank to the west of you and bounces back at your house from the direction of the west, and it comes in off the west antenna, right? I mean, these are all things we have to worry about here. So in the end, if you're going to combine two antennas in that perspective, I would think that you may want to just bring in two dedicated coax lines or switches or something like that. I wouldn't recommend doing that, but everybody's got their own unique situation. Now, again, I'm talking two Yagi antennas in about the same frequency range. Okay. All right. So let's finally clear up some issues when we talk about diplexers and duplexers. Now, diplexers and duplexers, they are two different animals, but they kind of do the exact same thing, but differently. Now, again, when I moved into the amateur radio to commercial world, duplexers and diplexers had me kind of confused a little bit, because in the amateur radio world, diplexers have been mislabeled as duplexers. So when I went to add diplexers to a commercial site, I'm like, well, aren't these duplexers? And then when you look at duplexers in a commercial site, it's like, but that's also a duplexer. Diplexers have a wide separation between frequency A and frequency B, the low frequency and the high frequency. They're easier to design. Okay, they're usually very small LC circuits. You can hide them in small outdoor boxes, those kinds of things. They're usually fairly inexpensive when compared to duplexers as well. I mean, you can find diplexers for $20 and up, right? Triplexers a bit more. Duplexers, again, are usually made out of cavities or cans, matching networks. They're tunable, but they are used for frequencies that are very, 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 very close together. Think of same band combining, right? It's exactly the same thing that we're doing here. And again, you can find same band combiners and probably use them in our other example up above too. But again, these are typically ground-mounted equipment when it comes to duplexers because of the size of them. When it comes to diplexers, triplexers, quadplexers, etc., you can mount them indoors and outdoors. They're small enough that you can shield them from the elements. Okay? So that is definitely something that we need to get straight. And no thanks to the amateur radio market when they mislabel everything. Just in this example, it's definitely one of those deals. So if you're looking for a diplexer, I recommend you look for, say, amateur radio hardware. Go to hamradio.com, gigaparts.com, AES Ham, MFJ Enterprises sells them as well. But you can look at them, look for duplexers if you're looking for a diplexer, and that is exactly what you want. All right, so how did we do? Combining antennas using hardware, duplexers, diplexers, triplexers, quadplexers, etc., etc., etc. You can download the session notes by going to scannerschool.com/session151. And remember, you can check out our weekly nets on Zello, scannerschool.com/Zello. But also, make sure you subscribe to the podcast because we have some really good stuff coming out for the rest of the year. And if you pick out your phone and you go into your podcast player of choice, again, we're on Apple's Player, Google Player, whatever that one is, Stitcher. We're on the Amazon device now as well. You can ask us to go over there. TuneIn Radio. I think whatever's out there as far as podcasts, I think we are available on there. So make sure you share this podcast with your friends and let them know that you can find us all over. Because the only way to help your scanner buddies and those who are in the hobby is to share the podcast. So again, go to scannerschool.com to make sure you sign up for our newsletter and also the show notes. And my name is Phil Lichtenberger. This is Scanner School, where we teach you everything you know about the scanner radio hobby. We'll catch you all again next week. 73.